Hi, my name is Pete Roberts, and I work for the South Dakota State University Jerome J. Lohr College of Engineering as its coordinator of recruitment and outreach. Today I'm going to talk about some STEM careers, specifically those that relate to our college. So the acronym STEM, of course, stands for Sciences, Technology, Engineering, and Mathematics. And obviously these are people that use a lot of logic, a lot of math, a lot of science to help solve problems and that type of thing. So obviously you can see some of the various areas for each letter of STEM that are fairly commonly accepted in that part of it. And then as you can see, the ones that we have at the Lohr College of Engineering are highlighted in blue there. And so as you can see, we do have quite a few of them, particularly from the kind of applied science engineering perspective, and then certainly a lot of logic-based things like computer science, data science, math, and statistics. So anyway, what do these kind of people do, specifically like the ones that we have in our college? So engineers use the application of math and science, specifically like in applied physics, to create something of value from our natural resources, whether that's created as a brand new invention or making a process or a thing that already exists better. Computer scientists use software and hardware to create digital systems. Obviously, there are a lot of things in our world that have a digital component to them. Mathematicians analyze data and apply mathematical and statistical techniques to help solve problems. And ultimately, these people are problem solvers. So if you've got an interest in problem solving, kind of tinkering with things, asking why a lot, that type of thing, that's a great first start. And then, of course, these people, ask a lot of questions, gather a lot of knowledge, or apply knowledge that they have that's their own or that is in teams. There's a lot of things nowadays that are crossovers between various disciplines, so there are a lot of different people with a lot of different experiences that work together to help solve problems. And then, of course, the engineering process really boils down to designing, building, and then testing the build, and then starting again as you need to, continuing to make those tweaks. I have some example of some people in my social circle and what they've done over the years as various jobs. I know somebody who programmed regulators on valves for hydrocarbon flow, and so there are regulators on these valves, and the regulators are basically like the electronic control system that controls, for lack of a better term, the paddle that's inside the valve. And so the regulator has sensors on it that track pressure, temperature, volume, flow rate, other important things that are involved in the process of pumping various hydrocarbons through pipes. And so I knew somebody who programmed those and used computer science in that realm to be able to program those regulators, and a chemical engineering knowledge to understand the properties of how those hydrocarbons work. I also know somebody who does some research and development at a cereals grains type of company and works on new recipe combinations for them. I also knew somebody who was a computer science major who worked at a cybersecurity company where they're testing out other companies' vulnerabilities. They hire them to come in and kind of take a test of their environment and see how their environment is put together and make sure that it's working okay. I also know of somebody who works for an energy company helping to manage the grid, just doing a lot of work to make sure that the grid is able to handle all of the load and adding new lines and different things like that. I know somebody who used to work in Daktronics, which is a company that is headquartered in Brookings, South Dakota, and has a good relationship with SDSU, who worked on the STAT software, programming that and the interfaces between their software and the video display equipment that they have. They make several scoreboards, video boards, things like that. And so that's been something that I've had a lot of experience in, because that is one of my hobbies, is working with stats software and taking stats at athletic events. And I've had the experience of working with that person and being able to learn more about their system and getting to know them and how their interfaces work. So engineering, again, can be broken down into 3 steps. And when people think engineers, a lot of times they'll think vehicles or something like that. So, here's the design, build, and test, maybe for a car, and some of the example questions about what they might ask. However, my point is of posting this slide is to take me into the next slide. You can basically take this same process and apply it to really anything that's ever been created. So here's a very simple thing, a payment terminal at a store. So the design, what's kind of the layout? How fast should it go in terms of like networking speed and that type of thing? And then the build, how does it fit together? Where do we get these materials? How fast can we build it? Testing, will it go fast enough? Maybe this thing's used outside. Will it be okay in the cold and in the heat? So these are just some examples of some of the various questions that engineers might ask as they go through the design, build, and test process. I like to bring up a cell phone as an example because it's a real common thing that we have, but has developed very rapidly over the last number of years. I mean, the thing has only existed about 35 years as of the recording of this video. It was invented in kind of the early to mid 80s. So your cell phone today has more computing power than NASA had to send people to the moon back in 1969. And there are several different areas that we have in our college that relate to how your cell phone works. And so mechanical engineers, study material properties and that type of thing. And of course, there's a lot of heat transfer. You've probably felt your phone getting warm at times and that type of thing. Mechanical engineers work a lot on that. The power distribution and the circuitry, obviously, in it. Electrical engineering or our electronics engineering technology program work on that. The infrastructure of the cell towers, whether that be, the concrete, steel, and the, kind of the power system that makes those run. It's definitely civil engineers that work on the structures themselves and electrical engineers that work on the power grid and that type of thing to figure out all those specs. And then, of course, computer scientists, somebody's got to program the operating system and the apps that run on your phone. And then computer science and data science and math are working on data analysis, management. When you put some input into your phone, maybe you've seen where, you're shopping for something, and then all of a sudden you see more ads for that relates to data science. There, obviously the advertisers out there are like, oh, hey, you are interested in this, so we want to advertise all these different options that you have for this. I do like to bring up an example about how engineers have been involved with your day. I feel like STEM and engineer people from like our area don't get a lot of attention unless something negative happens. And so there's a lot of things that just happen during the day that are just part of your day that you kind of take for granted. So, right, you probably woke up this morning, maybe to a device. That device had electronics in it. Those, of course, were made by engineers, STEM people. Generating and delivering the power to your house, taking all the power sources and combining them to work together on the grid, whether that be solar, wind power, traditional, steam-generated power at a plant, that type of thing. Designing the right size and material wiring and insulation for efficiency and safety, so even down to that detail in your wall. If you took a shower this morning or lately, water doesn't come out of the ground typically hot. So extracting energy from a source to add to your water to make it hot so that you have hot water for your shower. If you ate anything that you didn't just pick, pick and eat basically immediately or can or whatever yourself, the engineers are involved in the planting, harvesting, processing, and shipping of things like the cereal you may have eaten for breakfast or eggs and bacon, whatever the situation was for you. Certainly, the redesigning of the vehicle that got you to school or wherever you're at viewing this, extracting the energy to power that thing, creating the roads and bridges that you drove on to be able to maneuver that to your proper location, all involved engineering involvement. And of course, designing the equipment to harvest trees and process them into paper. So if you use paper today at all, there have been engineers involved in that process, taking a tree and boiling it down and all the processes that they do to it to make it into paper. And then, of course, as I discussed earlier, the design, powering, and the networking of the cell network for your smartphone to be able to communicate. Just kind of a short list of how STEM people and engineers have been involved with your day. So as you prepare for STEM in college, there are certainly some foundational classes of engineering that we highly recommend that you put yourself in a position to be able to take calculus, physics, and or chemistry. Pre-calc is even okay too, but those are the foundational classes of engineering. We also highly recommend being able to participate in or take a speech class, a communications class. So our people have to have some knowledge, but they also need to be able to communicate that knowledge, so that's important. Technical writing's great, or some kind of writing course, or something hands-on, is great too. If you can take industrial arts or a motors class or something robotics related, maybe your school has Project Lead the Way. Those are all great foundational classes to be able to take. So something that allows you to study the math and science, something that allows you to communicate, and something that allows you to participate hands-on are very, very helpful to pursue a STEM type major in college. So then, of course, everything out there has a pro and a con, right? Particularly when it comes, and specifically for this video, when it comes to different majors that exist. And so we, of course, have pros and cons. So the con is really the rigor. The first year of STEM in college is difficult. Again, it's that calculus, chemistry, and physics, and while you're transitioning from high school to college. But we have help in place that can help you through. We have several different study centers. We have our living learning community. So we have a lot of different things out there to help you in this transition. And then, of course, as the saying goes, sleep, study, socialize, pick two. Well, you certainly can do all three. However, it's all about time management. And really the saying is in reference to if you spend too much time on two of them, the third one will suffer. But then, of course, the pros. The pros are huge, and a lot of them are related to, certainly you can have a great experience while a student, but really the big advertised pros is that you're very, very employable. When you graduate with a bachelor's degree in any of these areas, you are really a master in your field. You have the education that you need to be successful. There are ample job opportunities. You're very employable. Great salaries that typically range between $55,000 upwards to $100,000 and more. We always say at SDSU that we don't have enough graduates to fill all the jobs that are available. So there's definitely some great opportunities for you if you're willing to come and learn and be a problem solver and make it through the rigor and graduate. You've really set yourself up for a lot of life success. I do want to take just a minute and go through some photos of some of our various things. We do a lot of building competitions, and so this is our quarter scale tractor, which is through our agricultural and biosystems engineering program. They make a small tractor that's powered, obviously a quarter size, and they take it to competitions and put it through different rigor. Here's our human performance vehicle, which is a very lightweight vehicle made out of like a carbon fiber body, and then you put somebody in it and take it around an obstacle course. We won this at the last competition that was held for this back in 2019, kind of pre-COVID. So the vehicle that you see that's kind of splotchy, gold and blue, finished first place at that competition. We also have our SAE Formula car, which is an opportunity to, as you guessed it, basically build a race car. And so a lot of our mechanical engineers, electrical engineers are typically involved in this project. Great opportunity to learn those skills and have the opportunity to build a race car. Our civil engineers participate, and others can too as well, in this competition that's a little different. It's called the concrete canoe. So you build a canoe out of concrete and then you row it across the lake, as you can see in a picture there. Typically, concrete is heavy, so you have to make it a very thin layer of concrete and make it very lightweight. But at the same time, you've got to make it strong enough so that it doesn't just collapse as you're rowing it across the lake. This is one of our labs that we have. Certainly, I think must be our largest. Our lower structures lab, where we're testing we test a lot of building materials, concrete, wood, steel, different things like that. We do a lot of work for the Department of Transportation, where we'll pour different sections of things that they're going to do out in the field, and then we'll test it to see, where's its failure point. So we have some pretty heavy duty equipment that can test these various structures. Here's another example. We have this microgrid lab. So basically we're working on determining, there's all these sources for electricity. And so we've got to get those together in a very smart and efficient way on the grid for use, for residential electricity usage, commercial electricity usage. And so we're doing a lot of work studying how to make all those power sources be on the grid in a very smart, efficient way. This is our art lab. The A in art stands for aeronautics, which means this is not drawing. They're actually studying drones. A couple of things that they're doing here. They're working on making drones that can be kind of autonomous in that drones don't have sensors on them right now. If you run a drone into a wall, it will hit the wall and it will fall. We're working on systems that will allow the drone to sense where it's at and not allow itself to be run into a disastrous situation, basically, that type of thing. So several different other projects that we're working on, but that's just an example of one. We also have an image processing center, which helps calibrate satellite imagery for entities such as arrows and other things that ultimately probably end up on like Google Maps and that type of thing. So these are just some scans of some pictures that we've received over the years of some various satellite imagery that they've taken for some different areas. Just some examples of some of the different lab research centers that we have available at our institution.